Mr. John Harding.
Thank you for those very kind words of introduction. It really is my honor to be in Asia, to come to this beautiful region of the world and speak at this meeting today. In my presentation today, there are a number of points that we'll cover. First, starting with the discovery of the syndrome PMWS, which led to the discovery of circovirus type 2. We'll spend a small amount of time talking about the PCV strains as well as potentially differences in virulence, and then move into clinical signs, discuss viral load and why it's important, both for diagnostics as well as for controlling the disease, and then finally closing up with different mechanisms and means we have of control and preventing circoviral disease. So to begin with, this is Western Canada. The portion of Canada that I live is represented by that big yellow star in the middle of the page, and this is where the discovery of circovirus begins. In 1994, we observed in a 600 sow, very high health unit, and in Canadian standards, back in 1994, high health meant free of PRRS, free of mycoplasma, APP, TGE, and virtually all of the diseases. And in this particular farm, the first lesion that we saw, and very much unbeknownst to us at the time, was a very large kidney, as is represented here on the lower right-hand portion of the screen. It's positioned above a kidney from a pig of similar age, and you'll notice a difference in color, as well as on the diseased kidney at the top, the focal white nodules that are on that kidney. And in situ in the carcass here, you can see these very, very large kidneys. Now, the pig also demonstrated anemia, weight loss, and had some focal white necrosis on the liver. We submitted the pig to the lab and asked them to clarify what was the matter with this pig, and really they had no idea. The only thing they could come up with was that it had some roundworm infestation of the liver, which was really quite an incidental finding. So we put that lab report in the file and thought that case was closed and we maybe wouldn't ever see that again. And lo and behold, within several months, the mortality on that farm went from a baseline of 2%, and that is 2% from nursery to finish, right up to 8%, so a fourfold increase in mortality. Now, in Southeast Asia, you'll be very happy with an 8% mortality level in nursery to finish. But keep in mind that this is a farm that is free of virtually all diseases, including PRRS. And at the time, this was a very serious situation on the farm. Lots of pigs were dying, and we really had no idea what was causing it, and in fact what to do to control it. Clinical signs similar to what we see today: pigs losing weight, turning pale, some of them turning jaundiced, and as well suffering from respiratory distress. We performed a very extensive diagnostic investigation, doing more than I have done in any other herd in my life, including clinical pathology, measuring immunoglobulin levels. We looked for all known mycotoxins, and all turned negative, or all were negative, as well as performed mass spectrophotometry looking for toxins in both feed and water. So we really pulled out all the stops and felt very guilty about having to charge the farm so much for these diagnostic tests when we weren't providing any answers to them. And ironically, the problem went away. We really didn't do anything that I think led to this. It did start to go down, and in fact, it did go down to baseline level, back to the 2% within about a 16 to 24 month period. We were relieved. We were curious what we maybe did that made the problem go away, and I don't really think we had any answers at that point in time. So my colleague, Ted Clark, positioned here in the bottom right, Dr. Clark was the pathologist at the Saskatoon lab. I was the field veterinarian about an hour away. We published our findings in the Western Canadian Association of Swine Veterinarians proceedings. up here in October of 1996, and then thought the case was closed. By that time, we had made an association with cirovirus, had grown it successfully in the lab, and we're thinking now with the last case. The types of mortality that we saw on that particular farm were summarized here in the bottom left. Lots of pigs with jaundice, lots of pigs with dyspnea, and then lots of just very unthrifty pigs. At the meeting in October 1996, another veterinarian from the province of Alberta, this is the province where the Rocky Mountains are located in Canada. It's a very beautiful province, and they have some pigs as well. And he said, you know, I have been seeing pigs like this for the last several years in my practice. And that was the first message that we had, that we were dealing with a new syndrome that affected more than one herd in Western Canada. So we quickly made a farm survey, polled the producers and the veterinarians what they're seeing, published our findings in the Journal of Swine Health and Production in this proceedings right here, and this is the first peer-reviewed publication of PMWS globally. Now, ironically, in 1991, in Western Canada, there is a small Mennonite farm, 40 sow farrow to wean operation selling pigs at 25 kilograms to a neighboring operation that had gone through a very similar outbreak causing respiratory disease and jaundice in pigs. And this was a newly depopulated farm with new stock. Diagnostic investigation had been performed in 1991 on that farm, and no diagnosis was made, and the problem had gone away. And after we discovered cirovirus and its association with the PMWS, we pulled the slides and blocks from this particular farm that were in archive at the laboratory and tested them for cirovirus. And in fact, lo and behold, this farm was positive for PCV2. So this, in fact, is the first index farm of cirovirus in Canada, 1991. And sometimes I'll refer to Canada having two index cases, one in 1994 and one in 1991. Since then, cirovirus has been diagnosed everywhere in the world, with the exception of Australia, which to this date, as far as I'm aware, does not have a diagnosis of ciroviral disease, although the virus is present on the continent. At the American Association of Swine Veterinarians meeting in 1997, Ted, Clark, and myself met with a group of French veterinarians from the Brittany region of France, which is represented here, the picture of France with all the dark dots there. They were noticing a similar situation in Brittany. They termed it pig wasting disease, and eventually we discovered that we were really working with the same syndrome, and now we had a globalization of the disease PMWS, or what we now know as PCVD. Ironically, after these cluster of farms in Western Canada in 1995 through 1996 and 7, PMWS or PCVD really did not cause any problem at all. In Canada, farms were all positive, and this picture here, the top right, is a picture of the serologic profile of farms from dry sows, virgin gilts, bred gilts, and then older parities, right through to pigs at 3.5 weeks of age, 9 weeks of age, 16 weeks of age, and then 24 weeks of age. And you can see that sow titers are largely positive, finisher titers are positive, and there's a group of pigs here at a young age which have generally low titers. Ironically, regardless of clinical sign, all sows or all farms have the same serologic profile. And at the time in 1998, when I tested 30 farms across the country, every single finisher pig in every single farm was in fact positive. So that was irrespective of whether there was clinical signs on the farm. In the province of Quebec in eastern Canada, they had a syndrome called proliferative necrotizing pneumonia, or PNP, and at the time we thought that was caused by swine influenza virus. Now we know that this is a combination of swine influenza virus, PRRS, and cirovirus, but as early as 1992 there was evidence that we had ciroviral disease in a very mild form in Western Canada, but not in any epidemic form that anybody would be concerned about. That all changed though. In 2004, In spite of the fact that Eastern Canada was largely positive for circovirus, it came back, and it came back in a big way. So 20 to 30% mortality in Eastern Canada, largely due to wasting pigs, respiratory disease, enteric disease, including diarrhea and gastric ulcers. And this picture here is meant to demonstrate the increase in caseload related to PMWS entering the diagnostic laboratory in Quebec, and we have a similar graph from Ontario, from all different types of farms. The syndrome, high mortality syndrome, which was in the early days in the US referred to, appeared to flow or transmit or spread from eastern Canada down into the US southeast, US Midwest, and then into western Canada. And I'm not sure it literally spread or whether it's just recognized in those areas. But by early 2006, we had early 2005, in fact, we had a very bad epidemic across North America caused by circovirus that resulted in high mortality. Had a tremendous response from the AASV and the National Pork Board in producing a publication, which is still online, available for those who are interested, describing the syndrome and helping producers manage the problem before the availability of vaccines in North America. So the question is, what is circoviral disease, and when does a pig have circoviral disease? And from a North American perspective, and I think a global, but maybe easier in North America to wrap our minds around this. Firstly, pigs need to have clinical signs, and that would include wasting or ill thrift or loss of weight. We look specifically for 2 histologic lesions, and in all cases of circovirus where I suspect, if I'm trying to attain a diagnosis on a farm, I will submit tissues for histopathology looking for 2 things. First, evidence of granulomatous inflammation in specific organs, and secondly, depletion of the lymphocytes in lymphoid organs. When I see that, I always ensure I can demonstrate PCV2 antigen in the lesion, and the gold standard test in North America for this would be immunohistochemistry. So 3-point plan in diagnosing circovirus: clinical signs, characteristic histologic lesions, and demonstration of PCV2 antigen in the lesions. At present time, I consider circovirus a combination of different clinical expressions. Refer to them as PCVD or PCVAD, both are interchangeable terms. The first would be PMWS, or multisystemic wasting syndrome, so that would be loss of weight and the disease in a number of different organ systems. That may be seen individually in a given pig, or we may see that in a very epidemic fashion, causing very high mortality on some farms. By European and North American definition, that would be either a doubling of post-weaning mortality over baseline norms. The Europeans like to use mortality greater than 1.66 standard deviations over historic levels. We may also see enteric disease, we may see respiratory disease, and on very rare situations we may see reproductive disease. Nobody's laughing at me, so I think I'm reading these Chinese characters correct, but point it out if I'm wrong here. Reproductive disease, and when we see reproductive disease on farms, and I believe personally I believe that's a very rare event, the diagnostic gold standard for that would be the demonstration of prenatal myocarditis in stillbirth pigs, in which you can demonstrate both the myocarditis as well as the PCV2 antigen in the heart tissue. Down in pink, I've placed a PDNS. That's obviously the porcine dermatopathy and nephritis syndrome. It seems to be clinically expressed with PCV2 or PMWS outbreaks on farm, and to this day, I think many of us are really unsure of whether PDNS is caused by circovirus or whether it's caused by some other agent. Nobody has experimentally reproduced PDNS with circovirus at this point in time. The closest that we've come to the experimental reproduction of PDNS is Steve Krakoka's work, where he has used PRRS and torquetenovirus to reproduce it, but To be very honest, I think the pathologists in the world are probably not on the same, or not in agreement with Steve on whether they have successfully reproduced it. So what is circovirus type 2? Well, first of all, it's an old virus. Or circovirus is an old virus. We've had two types. Circovirus type 1 was first identified in 1974 by Dr. Tischer in Germany, and it was seen as a contaminant of the PK15 cell line, and they have tried to reproduce clinical disease with circovirus type 1 and failed in every attempt. So largely seen as the non-pathogenic virus. PCV2 is pathogenic. It's genomically and antigenically unique from PCV1. It's ubiquitous and stable. It is everywhere. And I'm only aware of one farm in the world at the present time which is free of circovirus. And that farm is a research unit in France which uses HEPA filters to keep circovirus out of the farm. We consider it a necessary, but it's an insufficient cause, or by itself it does not cause disease, and it requires cofactors of various types in order to cause disease. The genome is very small. With circovirus, it's made up of 4 major ORFs and a number of minor ORFs, or open reading frames. ORF1 is the larger of the two, and it codes for viral replication, or the gene that's involved in viral replication. ORF2 is still reasonably large, and it's the gene that codes for the capsid, and the capsid is this green outer shell that is surrounding the DNA. Inside the capsid, there is a single strand of circular DNA, which is characteristic of all circoviruses. There's a third ORF, which we believe is involved in apoptosis, which would be part of the pathogenesis of the virus. And then there's a fourth ORF that we're not really sure what, in fact, ORF4 does, nor the minor ORFs. Circovirus type 2 are divided into different clusters. The picture I show up here is one that I've shown a number of occasions before. These are strains that are posted on GenBank, and you can see they largely cluster into type A and type B, maybe referred to as old strains and new strains, but I don't think that's as clear cut at this point in time. There's also many different terminologies used to describe these clusters. In Canada, some of the early publications were 321 and 422. Another very popular way is genotype 1 and genotype 2. And by consensus now, the Europeans are moving toward calling the strains 2A, 2B. And in fact, there is a 2C that is a grouping of circoviruses, or an isolate of circovirus that was found in Denmark back in 1980, before we knew anything about circoviral disease. It's genetically unique. The clinical signs of circovirus are very consistent around the world, include weight loss, wasting, pale pigs, diarrhea, and respiratory disease, and very uncommonly jaundice. And in Canada, when we had this epidemic, 2004, I performed a survey to, ask the question, are the syndromes or the clinical signs similar today as what we saw 10 years prior? And yes, they're very similar to what we saw in the mid-1990s. The only exception will be that we've diagnosed more gastric ulcers today than we saw in the mid-1990s, and more PDNS than we saw in the 1990s. In fact, I did not see a case of PDNS until early 2000s. We did not see that at all in the early cases. So here's some pictures of unthrifty pigs. Here's an example of an early case in the nursery in Canada. This is very typical of nursery pigs on totally slatted flooring, and this pig you can see is drooped. He's smaller than his pen mates, and quite often we gather these pigs up and put them into hospital pens, and they continue to see signs of weight loss. Some recover, many don't recover. And this is a picture down here of pigs that are slightly older. These are about 15 weeks of age, and we have typically gathered them up in past and waited for them to recover, and most of them don't, so now we tend to euthanize them more quickly and move on. Enlarged lymph nodes are very commonly seen with circovirus, and one of the best lymph nodes I tell my students to look for is the superficial inguinal node, which is seen here. So this is the tail of the pig down at this end. We're looking at his ventral side, and they're very large very large lymph nodes. This is a picture of an experimentally infected pig by Dr. Bolin in the U.S., and you can see there are some very large lymph nodes here, and they almost look like retained testicles on that pig. They're so big. Another good example of enlarged lymph nodes is the chain of mesenteric lymph nodes that we see down in this picture on the bottom left, and they're quite often very much enlarged. Periodically, we see enlarged mediastinal lymph nodes or bronchial lymph nodes. Typically, the bronchial lymph node in a pig is not seen. You have to dissect very carefully down through the aorta to actually see them. And you can see in these pigs, this is actually a pig from the original outbreak. With respect to the lungs, we can see various lesions. Here we see a picture of a lung which has failed to collapse. It's got a patchy distribution. This is actually a lung from the original outbreak as well. It's PRRS and swine influenza free, but you can see this patchy distribution of purple area here, some consolidation. And then more recently, we see lungs that may look like they've got some bronchopneumonia as well as some pulmonary edema. Another organ that I ask my students to be sure they can identify in pigs when doing necropsies is the thymus gland, because the thymus is quite often depleted, either very close to 100% or maybe just very small remnants. And the thymus is positioned in the anterior thorax. It overlays the heart, which is this darker pink-purple area here, and it looks like fat. And if you look at it very carefully, there is actually tissue there that is non-fat. So this is a healthy pig, and this is a pig similar in age. We've opened up the chest cavity, and you can see where the yellow arrow is. There's, in fact, no thymus left in that pig. And in pigs, all adults obviously will lose their thymus as they get older, but in finisher pigs, I've found that there's still fairly large remnants of the thymus that can be close to market weight. So in a young pig, the absence of the thymus, I think, is very significant and characteristic of circovirus. We also see jaundice as well. It is not a very common clinical sign, but when we see it in Canada, there's really no other diseases that'll cause it, so I think it's very diagnostically significant. Here's a picture of a yellow pig, and this is the end-stage kidney in that particular animal. Obviously, it's a terminal event when they turn yellow, so take a picture because the pig's probably not going to be around for very long. We obviously see kidney lesions. Interstitial nephritis is more characteristic of circoviral disease, not discussing PDNS at this point in time, but multitude of white, small to medium-sized foci on kidneys. One of the new lesions that we saw in PMWS or circoviral disease after it came back into Canada was edema, very, very extensive edema. And here we see a lung with these black lines through it. It's all pulmonary edema. This pig is actually drowning in its own fluids, as is this pig here. Very, very extensive hydrothorax in this pig, and you probably can't see it, but there is some ascites in this pig as well. And we don't have classic swine fever in Canada. PDNS, may or may not be involved with circovirus. I guess we're still sitting on the fence. Very nice splenic infarcts of all different shapes and sizes. We don't have swine fever, so this obviously does not point us in that direction. When I went through school, splenic infarcts were pathognomonic for swine fever, but we obviously know that not to be true. And then various GI ailments leading to diarrhea and gastric ulcers. So the hallmark lesion for us for circovirus is the depletion of the follicle in the lymph node. Here is a normal lymph node. These pictures are courtesy of Dr. Halber. You can see the dark purple area here, which is the B follicle in the lymph node, and in this particular section here, we have an absence of the lymphocytes as well as we've got granulomatous inflammation. So when do pigs become infected with circovirus? Well, this is a characteristic pattern of seroconversion in most farms. We see that there is evidence of colostral antibody at birth. There's tremendous range in circovirus antibody at birth as there is in just total IgG. But over time, the antibody levels drop. In this particular farm, they drop at 6 weeks. This is a group of 60 pigs which were bled at 4 to 5 days of age and then every 2 to 3 weeks throughout their growing period out to 19 weeks of age. So colostral antibodies drop, the tremendous variation in every age point, and then at some point in time those antibodies tend to increase. It typically is in the late nursery or early grower phase, and the increase in antibody levels correspond with increasing levels of DNA in serum, or the pigs become viremic. And again, there's variable levels of virus. You see some pigs have very high levels of virus. What we're measuring here is logs of virus detected by quantitative PCR. If the pig has anywhere above 5 log, it's probably one that's quite sick, and if it's less than 5 log based on the PCR that we're running in our lab, then it's more likely to be healthy. So viral load is important. It's important because it correlates with clinical disease. The more virus that is present in the pig, the more likelihood, the greater likelihood that that pig is clinically ill. In lesions, the more virus that's in the tissues, the more likely that that pig was in fact unhealthy. So this chart is one of Dr. Brunberg's. It's, I think, published in 2004. We see healthy pigs and we see pigs with circoviral disease, and in both lymph node and serum, the healthy pigs have lower levels of virus. So PCV load in serum and in tissue is obviously related to clinical disease. It's correlated with the amount of antigen staining or nucleocapsid staining in tissues. It's correlated with the severity of lesions that we see. And more recently, really after the advent of circovirus vaccines, we are learning that viral load is also correlated with average daily gain. So this is a chart that I've just run off a trial in which we measured viral load in serum of healthy pigs from birth to 19 weeks of age, averaged over the 6 different time points. And lo and behold, there's a negative correlation that as viral load increases, average daily gain decreases. And the relationship, although there's a lot of variation still in this, but the relationship holds true that 1 log increase in viral load is equivalent to a 33 gram per day drop in average daily gain. And one could argue that this is just a single farm in Saskatchewan where we did a trial, but ironically I sat down with my colleagues in January, and in unvaccinated pigs in different continents, the same relationship holds true. That for every log increase in viral load in serum in subclinically affected pigs that look like they're healthy, average daily gain drops. And that is one of the major benefits of vaccinating pigs. So how do we diagnose? Well, I think in Asia and everywhere else in the world, that starts by doing a gross postmortem and looking for the classic gross lesions. In areas where you have a diagnostic system that will accept tissues, then submitting lymphoid tissues and non-lymphoid tissues. Many different types of tissues from many different types of pigs will go a long way in helping you diagnose. Avoid sending a few tissues in from single pigs. Clinical signs and lesions are going to be inconsistent across different pigs, so why not spend lots of money and try to get it diagnosed right the first time? We're looking for, obviously, those characteristic lesions of lymphoid depletion and granulomatous inflammation, and most importantly, you need to demonstrate presence of antigen in the tissue. So if immunohistochemistry is available, that's fantastic. If in situ hybridization is available to detect DNA in tissue, in lesions, that's fine as well. I guess if PCR is all you have available, that's better than nothing, but certainly that does not meet the standard of seeing the virus in the tissue. Ensure that you diagnose all of the diseases on the farm, and this is particularly important in Asia just because of the number of different diseases that you have. The opportunity for co-infection is certainly there. This is a study from Quebec, Canada, where Cargagnon has identified different infections in these pigs that were epidemically infected in 2004. And we have everything from PRRS virus to swine influenza, parvovirus, hepatitis E virus, which is one that we try not to think about too often, as well as torctenovirus and Mycoplasma hyarinus. So even in Canada, which is high health, we can still identify all sorts of other pathogens in these pigs. And why is that important? Well, as a non-immunologist, I will try to explain what I know about the immunology of PRRS virus, which can be condensed down into about one slide. And I'll take you through what kind of is the normal situation. There's a cell called the dendritic cell, or the plasmacytoid dendritic cell, which is an antigen-presenting cell, very fundamental part of the innate immune system, also called the natural interferon-producing cell. And it responds to danger signals. And Dr. Murtaugh referred to danger signals this morning, and that's what this particular dendritic cell does. Now I'm going to ask that we try to keep up here so we get simultaneous. What this dendritic cell does is it produces interferon alpha and TNF alpha, and that allows another subset of dendritic cell to mature, and that's called the myeloid dendritic cell. And this is all part of the innate immune system, and then ultimately through many different processes, the adaptive immune system is then put into action, producing both the humoral or antibody arm of the immune system, as well as the cell-mediated arm of the immune system. So that's normal. That should be happening in normal healthy pigs. And what we see in circovirus-infected pigs is circovirus infects the dendritic cell. Circovirus accumulates in those dendritic cells. The immune system still responds, so still produces IgG, but the recognition of these danger signals is impaired to some degree. And with that, then the cascade of cytokines that help those myeloid DC cells mature is impaired, perhaps leads to more infection of circovirus, which then ultimately all or part of the cell-mediated and humoral immune system then is impaired, and ultimately that leads to secondary infections, and the story continues. So how do we control circovirus on farms? Well, before vaccines were available, particularly in Western Europe, where they had a lot of circoviral disease, they focused on good production practices. And I'm sure everybody's heard of Dr. Francois Madec's 20-point plan. And in farms where you can implement as many of these these points as you can, then you have some degree of success in controlling circovirus. And these are not specific to circovirus by any means. These are just very good production practices, and we can't forget them. We need to control other diseases, prevent immune stimulation. These are very good, but also very difficult things to do on most farms. It takes a lot of time, and it takes a lot of work. So they're great, let's not forget them, but boy, in North America, we were sure happy when vaccine came. So ironically, after 7 to 10 years in development, circoviral vaccines arrived in Canada to correspond to about the month that the circovirus outbreak occurred. So if it started kind of in late 2004, November 2004, by spring of 2005, we had a couple of these vaccines on the market. So there's no question that vaccines are very, very successful in reducing mortality. Nobody in North America questions that anymore. I think what we are really going to focus on in the future is how much of an improvement in average daily gain do these vaccines result in. So there are 4 different vaccines on the market. There's one that's designed for sows, and there's 3 that are designed for piglets. And certainly I'm not aware of why the companies chose their different routes of inoculation. Some of these vaccines, 2 of them, Intervet's product and BI's product, are subunit vaccines. They contain only the capsid protein. They're produced in baculovirus, as I'm sure many of you are aware. The Fort Dodge vaccine is a chimeric product between PCV1 and PCV2. So what I'd like to do now is just end up with a few slides on how successful these vaccines are. And given that it was a BI meeting, I thought it was probably not best if I presented some research from other companies. So this is not an exhaustive review of all the literature, but it is certainly gives you a broad base for trying to make a decision on what to expect when vaccinating. So this is piglet vaccine specific to Circoflex, and the first comment is they reduce mortality. And in North America, my subjective view is that we can probably achieve a 90% reduction in mortality. In other parts of the world where there are more diseases present, success or reduction in mortality is not as great, but there's no question that you'll see a drop in mortality. So this is a farm in England where we see about a 75% drop in mortality, and this is a farm in Italy where we see about a 50% drop in mortality. Now, pigs on farms die at all ages, and if we have pigs dying before the onset of viremia, which let's assume is going to be 6 to 7 weeks, the vaccine will not prevent mortality that occurs prior to viremia. Obviously, that's not caused by circovirus. Can't expect a circovirus vaccine to have any benefit. However, in mortality that occurs after viremia, you should expect a tremendous improvement, somewhere, I guess, between 50 and higher percent. Secondly, in pigs that don't die, we should also see a drop in clinical signs. And again, it occurs after viremia. And in this particular study, we see a drop in number of pigs that were wasting, coughing, dyspnea, pallor, and lethargy, and as well lameness. And you may ask, why would a circovirus vaccine decrease the number of pigs that express lameness? And lameness is not really characteristic of circovirus. And it may be that circoviral vaccines are helping to control some of the other cofactors just because the immune system is stronger. If you're in markets that sell pigs based on weight, like we are in North America, in Canada we sell pigs at about 120 to 125 kilograms, and that's live weight. If we sell pigs less than about 90 kilograms, we'll be penalized because the pigs are smaller as well as they fall off the marketing grid. And in normal proportion of the group that is below the market weight, and the vaccine is very successful in dropping the percentage of pigs that fall below the weight grid, and these may be termed suboptimal pigs by some or unthrifty pigs. So in this particular study, we have about 7 to 10% of pigs that are unvaccinated that fall below the grid, and that has dropped to somewhere between 2 and 2.5%. I mentioned that mortality is not an issue. Vaccines control mortality. We're very excited because we believe that even subclinically infected pigs, so pigs that are healthy but infected with circovirus, showing no other signs of disease, it will in fact improve growth of those pigs. And this is, I think, where there is a major economic benefit to using vaccine even in healthy farms. And what I'd like to do is watch these graphs as I progress through the slides. This is a bell-shaped curve here. The vaccinated pigs are in green and the unvaccinated pigs are in red, and these are pigs that are 3 weeks of age, and you notice that the bell-shaped curves are largely superimposed on each other. And what we'll see as we move into older pigs is the bell-shaped curve of the green pigs or the vaccinated pigs will move to the right as pigs become heavier as they get older. And as well, the peak of the curve gets higher because we have more pigs and less variability, more uniformity in the age group. So by 10 weeks of age, you can start to see that the pigs are more uniform and they're very slightly heavier. Move that green line over to the left. And as we move on into the next age group, at 15 weeks of age, where are we? Okay, there we go. At 15 weeks of age, you can see here, we now have a very high peak and we've moved to the right, and the benefits that we see at 15 weeks are largely maintained at 23 weeks of age. Now the question may be asked, what about maternal antibody interference on vaccine? And that's obviously a question. In Canada, we typically vaccinate at 3 weeks of age. There have been some that have vaccinated as young as 5 days of age at processing on an off-label situation. But at 3 weeks of age, the question has been answered that maternal antibody interference is not particularly important. This is a study where the researchers measured average daily gain in both vaccinated and non-vaccinated pigs But at 3 weeks of age, they measured the antibody levels, and they categorized the pigs as either having high levels of maternal antibody or low levels of maternal antibody, and then compared average daily gain in those different groups. And they found that there's no difference in average daily gain maternal antibody levels do not interfere with response to the vaccine or average daily gain. So that's very positive. The caveat in this is these are unvaccinated sows. If you were to vaccinate sows with a piglet vaccine or Marielle's vaccine, I guess I don't know the answer to that. There's no peer-reviewed literature now that has answered that question for us. So I guess my recommendation would be cautious. So the best practices, how should we measure vaccine responsiveness on farms? Maybe I'll start by saying how should we not measure vaccine efficacy? Well, I think serology is not particularly useful for a couple of reasons. First, that all pigs are going to seroconvert to circovirus anyway. And secondly, because single-dose vaccines like Circoflex do not necessarily induce an antibody response in pigs post-vaccination. So I don't think serology is a particularly useful method of measuring vaccine efficacy, nor do I believe PCR is. And across all vaccines and across all species, vaccination does not prevent viremia. It protects against disease, but there will still be presence of virus in those pigs. So what's vaccine doing is really controlling viral load to keep the level of virus very low or as low as possible. So best practices for measuring vaccine efficacy. Well, let's stick to things that have an economic benefit on farms, because I think ultimately pig farmers need to make money, and return on investment is very important. So things that we can count on farms. We can count the number of dead pigs, and we can count the number of pigs that are being treated or are sick, and I think we can put an economic value on that. We can also measure average daily gain or days to market as well. We can measure the number of pigs that do not meet the appropriate market weight, or are being sold out into lightweight markets, and producers are being penalized. And with all of these, we can count, and in all farms, we should come up with an economic benefit to justify continued use of the vaccine. So in conclusion, PCV2 vaccination is very important. It's a tool that we can use. I think it's not necessarily a silver bullet, although producers like silver bullets just as much as veterinarians like silver bullets. But I think it's important that we continue to improve good production practices and biosecurity on farms to prevent circovirus as well as other diseases, and as well improve the efficacy of the vaccine. It's important to observe the manufacturer's instructions. Don't veer off label unless you have to, and make sure that you implement other non-vaccination control strategies for circovirus and other diseases on the farm. So with that, I would like to thank all my collaborators, and thank you for the opportunity, and thank BI for the opportunity to bring me to Asia, both to speak at this meeting and spend a few days in Philippines, touring with my esteemed colleagues in the Philippines. But most importantly, I would like to invite you to Vancouver, July 18th to the 21st for the 21st International Pig Vet Society Congress. Thanks very much. It's a pleasure to speak to you.
Thank you very much, Professor Harding. The floor is now open for questions.
I have a question. It is, can we eliminate PCVD from a positive farm? How to do it?
Okay, I heard three-quarters of the question. Can you eliminate PCV from a positive farm?
Mm-hmm.
How to do it?
How to do it? I don't think it's possible. I'll be honest. Given our technology, given that it's taken 20 years to figure out how to keep PRRS out of a farm, and it takes very special filters in order to do that, PRRS is different, because once a pig is negative for PRRS, it stays negative for PRRS until it's reinfected. Circovirus infects all pigs, and I think it infects pigs for a long time. And I was sharing with Dr. Murtaugh that we've done research on sows, and even older sows are shedding abundant circovirus, and these are third, fourth, fifth parity sows, abundant circovirus through milk and feces. So it appears that they stay infected for a long time. So at this point in time, I would just put that question on the back burner, and maybe my grandchildren will be able to solve that question.
Thank you.
All right. Any other questions? Professor Yang?
Dr. Harding, thank you for your nice presentation. So gave us a detailed description of PCV disease. So I have a concern associated with PCV2 vaccination. So in China, we have some data showing that PCV infection can happen in early as in before weaning. So what's your suggestion? How do we carry out vaccination in such a period?
Can I ask you a question? When you say you have evidence of ciroviral infection before weaning, I'm presuming that's before 4 weeks of age. And how have you diagnosed it? Is it based on PCR or based on lesions or?
Both antibody and PCR for the PCV2 nucleic acid.
Okay, so piglets are viremic. Is that what you're saying? They have a high antibody?
Yeah, there's some critical.
Yeah. So if we're in a situation where we have viremic pigs prior to weaning at 4 weeks of age, how I would handle that is, number one, I would test pigs at birth, pre-colostrum, because, don't forget, there's cirovirus present in milk. So I need to differentiate from my point of view whether that is occurring as a transplacental infection or whether that's occurring postnatally. It could be occurring in both situations. But ultimately, I think the control is probably going to point in the direction of using vaccine in the breeding farm. And with that, I guess the options are on-label with a Marielle product or off-label with one of the other products. But I suspect in that situation, you really are forced into breeding herd vaccination.
Okay, thank you.
Okay. One last question. Oh, okay.
It's a very interesting presentation that you have there. It's compound of two questions, okay?
Sure.
The first question is there any, based on some literature that I've gone through, they found that there is a differences of pathogenesis for PCV2A and 2B. Is it true? Then there is the early literature, it does mention that PMWS tend to affect age group from 8 to 15 weeks, but we found that it's more, they tend to affect earlier, about 5 to 6 weeks. Do you find that true as well?
Yeah, those are very good questions. So I'll answer the second one first as far as the, when circovirus affects farms. Ironically, when we published PMWS back in 1995, it was affecting younger aged pigs. So I suspect that depending on the farm and depending on levels of colostral protection, the clinical signs and the infection, the timing of infection may vary from nursery period out into grower and sometimes out into finisher. So I don't think that's that the virus is changing. I think it's just epidemiology on the farm is changing and the dynamics of infection, and I think there's lots of things that will affect that. The graph that I showed you is a farm that had about 15% mortality, and it was obviously affecting us kind of in the late nursery to more the grower period. So that was the first one. The second question was with respect to the different clusters, PCV2A and PCV2, and which ones are more virulent. And in fact, I have a slide, but I didn't go into that. If you look at the data that's published, it can be broken down into experimental studies and epidemiology. And the data is largely broken in half, that half researchers are proposing that the clusters are of same virulence, and others, about half of the researchers are proposing that there is a difference in virulence between the clusters. So I think the consensus is probably yet to be made. Personally, I'm leaning towards the fact that there is no difference in virulence. Under the right situations, you can clearly produce disease with PCV2A. 1994, that was PCV2A, and you can clearly produce it with PCV2B, as in more current strains that we've got. When you're speaking of control, though, it makes no difference whatsoever. The vaccine works against both. In fact, the vaccines are all based on PCV2A, and clearly they protect against PCV2A and PCV2B.
Okay. Thank you very much, Professor John Harding.